Imagine waking up tomorrow and the Earth is simply gone. Not destroyed in a fiery explosion, not shattered into drifting debris, but vanished, completely erased from the universe without a single trace. One moment you're here, surrounded by familiar streets, oceans and skies, and the next, nothing remains. The home of humanity has been pulled out of existence, as though it were never there in the first place. That thought alone is unsettling enough, but it's only the beginning of the questions that follow. What happens next? How does the rest of the cosmos respond to the sudden absence of our planet? And what does it mean for those who once called it home? This is the unsettling question at the heart of our exploration. What if Earth suddenly vanished from the universe tomorrow? The title itself sounds like science fiction, yet behind it lies a thought experiment that pulls us into the very fabric of reality, physics, and existence. When we dare to imagine this scenario, we're forced to confront more than just the science of orbits and gravity. We face the raw fragility of our own place in the cosmos. From a cosmic perspective, the disappearance of Earth would ripple outward like an invisible shock wave. The moon, once bound to us, would be cast adrift. The sun, seemingly untouched, would still feel the absence of our planet's gravitational tug. Entire planetary dynamics would shift in subtle but profound ways. Scientists might calculate the trajectories, but the emotional impact, the thought of home itself erased, pulls us into darker, deeper questions. Because beyond astrophysics lies philosophy. If Earth vanished, what does that mean for the billions of lives, histories, and stories bound to it? Does humanity simply end, or does this reveal something larger about the universe itself? These questions set the stage for a journey that is both scientific and existential, inviting us to peer into the unknown with both curiosity and unease. To understand the scope of this thought experiment, we first need to define exactly what vanishing means in this context. It's easy to imagine Earth being destroyed, hit by a massive asteroid, torn apart by a rogue planet, or consumed by some cosmic catastrophe. But destruction leaves behind evidence. Fragments of rock would scatter through the solar system. Dust and debris would remain as a faint scar of what once was. An explosion, no matter how violent, still testifies that something existed. Vanishing, however, is something entirely different. It means the sudden, absolute removal of Earth from the fabric of the universe without any warning, without any debris, without any lingering trace. 1 second Earth is orbiting the Sun, its blue oceans reflecting light into space, its cities glowing faintly in the night. The next second, nothing. The space where our planet should be is simply empty, as though Earth had never been there to begin with. This isn't a collapse or a transformation. It's erasure, a cosmic deletion. The implications of this are staggering because nature doesn't usually work this way. Physics thrives on continuity. Energy flows from one form to another. Matter shifts and transforms, but nothing just ceases to exist. Conservation laws, the backbone of modern science, demand that mass and energy are preserved. If Earth were obliterated by some natural catastrophe, that demand would still be respected. But if Earth were to vanish in the way we're imagining, those rules would appear to be broken, and the universe itself would seem to bend under an impossible condition. So, for the sake of clarity, we need parameters. In this scenario, everything tied to Earth vanishes along with it. The crust, mantle, and core. The atmosphere that surrounds it. The rivers, forests, deserts, and oceans. Every city and every human being, every living creature from the smallest bacterium to the largest whale, gone. Even the satellites orbiting Earth, artificial or otherwise, vanish with it, as though tied to the planet's existence in some fundamental way. If it belongs to Earth, it disappears in the same instant. But what about objects not bound directly to Earth? The Moon, for example, is a separate body, gravitationally tied to us but not physically part of our structure. In this scenario, it remains. The Moon would suddenly find itself alone, its eternal partner gone, orbiting nothing. The same goes for the Sun. It continues burning, unaffected at its core by Earth's disappearance, but the delicate balance of the solar system would immediately feel the absence of one of its members. The planets keep spinning, but the order has changed. That distinction matters, because it shapes the kind of universe we're about to explore. We're not imagining an all-consuming void erasing the entire solar system, nor are we imagining some hidden hand plucking celestial bodies at random. Instead, we are focusing on Earth alone, vanishing instantly, leaving everything else to grapple with the consequences. At first glance, you might think that the disappearance of one planet out of billions in the cosmos would barely matter. After all, the solar system has 8 planets, countless moons, and endless streams of asteroids and comets. Earth's absence doesn't cause the Sun to falter. It doesn't snuff out Jupiter's storms or pull Mars off its path. Yet the removal of Earth is not just about mechanics. It's about meaning. Earth is the only world we know that carries life, history, and consciousness. The physical hole it leaves behind is dwarfed by the existential one. Still, before we get to the emotional and philosophical consequences, we have to remain anchored in the physical stage setting, because the rules of space will dictate the first wave of consequences. From a purely physical perspective, the sudden disappearance of Earth would break several expectations we have about the way reality works. Normally, if a celestial body was somehow destroyed, even in the most extreme event imaginable, the gravitational field associated with its mass would gradually shift as debris scattered. But if Earth were erased in an instant, its gravitational pull would vanish along with it. This means that everything previously held in Earth's embrace, the Moon, satellites, and even the subtle tug Earth exerted on neighboring planets, would suddenly be set free. That absence would ripple outward, not as an explosion, but as a silent rebalancing of forces. The atmosphere, too, plays a role here. If Earth explodes, the gases of the atmosphere disperse violently, creating shock waves, fiery destruction, and expanding clouds visible from afar. But if Earth vanishes, the atmosphere goes with it. 1 second there's breathable air enveloping billions of people and trillions of creatures, and the next there's vacuum. There's no transition, no time to gasp or suffocate, no burning winds tearing across the surface. The atmosphere doesn't escape. It simply ceases to exist. Life ends not through struggle, but through absence. This framework of vanishing also raises questions about human creations beyond the atmosphere. The International Space Station, orbiting Earth at high speed, depends entirely on Earth's gravity to remain in motion. If Earth disappears, the ISS would vanish as well. The same is true for satellites, whether they're used for communication, navigation, or science. They are, in essence, artificial appendages of Earth's presence in space. If the planet goes, they go too, leaving behind only the things that were never fundamentally tied to Earth's existence: the Moon, the Sun, and the rest of the solar system. Such careful distinctions may seem tedious, but they are essential for painting a clear picture. Without them, the scenario collapses into confusion. By defining vanishing in this precise way, absolute disappearance without debris, affecting Earth and everything bound to it while sparing objects like the Moon, we create the boundaries of the stage on which this thought experiment will play out. Only then can we explore the consequences with any sense of order. And those consequences, as we will see, are both subtle and immense. The moment Earth vanishes, the Moon finds itself set adrift, its once stable orbit turned meaningless. The Sun, though continuing to burn, suddenly lacks one of its balancing dancers in the cosmic waltz. The gravitational tug that Earth once provided is simply no longer there. This is where physics begins to shift into motion, and the solar system as we know it starts to respond. The moment Earth vanishes, the solar system experiences a sudden, silent reconfiguration. There is no flash of light, no roar of destruction, no burst of particles to announce what has happened. Instead, the change is defined by absence. The invisible web of gravity that once tethered the moon, satellites, and even subtle aspects of planetary orbits is instantly broken. To an outside observer, nothing seems to occur in that instant. Yet within the structure of the solar system, the consequences begin to unfold with a precision and inevitability that only physics can dictate. The first and most immediate change concerns the Sun. Earth's gravitational influence on the Sun is tiny compared to the Sun's pull on Earth, but it is not zero. Every planet in the solar system tugs ever so slightly on the Sun, pulling it this way and that in a slow, almost imperceptible dance. If you were to track the Sun's movement through space over millions of years, you would find that it doesn't sit motionless at the center. Instead, it wobbles in response to the planet's gravitational pulls, especially Jupiter's, but also to smaller degrees from all the others, Earth included. With Earth's sudden disappearance, that subtle tug vanishes as well. The Sun won't care in any dramatic sense. It will continue fusing hydrogen in its core for billions of years, unbothered by the loss. Yet, in the precise calculations of orbital mechanics, the balance is altered. Earth's mass, though tiny compared to the Sun's, played a role in the exact positioning of everything else. Without it, the orbital paths of neighboring planets will very slightly adjust, shifting in response to a solar system that has lost one of its players. To human eyes, these changes might seem unnoticeable, but to astronomers charting trajectories over centuries, they would matter. Far more dramatic, however, is what happens to the Moon. For billions of years, the Moon has been Earth's companion, locked in a gravitational embrace that defines its orbit, its tides, and even its gradual drift away from us. That relationship ends in an instant. With Earth gone, the Moon is no longer orbiting anything. In that moment, it becomes a free-floating body in space, moving along the exact trajectory it had when Earth disappeared. To visualize this, imagine swinging a ball on a string. As long as the string is intact, the ball orbits around your hand in a steady circle. But if the string is cut, the ball doesn't stop moving. It flies off in a straight line, following the path it was on at that exact instant. The same principle applies to the Moon. Instead of circling Earth, it continues in a straight path through space, carrying the momentum it had at the moment of Earth's erasure. Where does it go? At first, it continues roughly along Earth's orbital path around the Sun, because while it was bound to Earth, it was also moving in tandem with Earth around the Sun. Once freed, it essentially takes Earth's place, following an independent orbit of its own. But because the Moon's motion was never perfectly aligned with Earth's, its path begins to diverge over time. Tiny differences in velocity and angle accumulate, and soon the Moon is not Earth's successor but a wandering body, one more small world circling the Sun on its own trajectory. This shift would be dramatic for the Moon itself. No longer pulled by Earth's gravity, its rotation and orientation could begin to wobble in new ways. The side that always faced Earth would no longer be locked in that eternal gaze. For billions of years, one hemisphere of the Moon has never seen Earth rise. Now that relationship is severed forever, leaving the Moon to spin freely in the void, a silent orphan drifting where Earth once stood. The consequences are equally striking for everything that once orbited Earth: satellites, space stations, fragments of space junk. These objects, unlike the Moon, have no independent momentum relative to the Sun. Their paths are tightly bound to Earth's presence. When the planet disappears, so too do they, if we are following the rules of this scenario. The International Space Station vanishes, communication satellites vanish, the fragments of old rockets and broken machinery vanish. Every trace of humanity's reach into space that depended on Earth's gravity goes with it. But what if, for the sake of exploration, we imagine that those satellites did remain, freed of Earth but not erased. They would instantly find themselves moving in curved trajectories no longer anchored by Earth's gravity. Like stones released from a sling, they would scatter, each one carrying its last recorded speed and direction into the vacuum of space. Some would drift along Earth's former orbit, effectively becoming tiny independent bodies circling the Sun. Others might veer off, their trajectories altered just enough to push them into different paths that, over centuries, could send them toward collisions with other planets or out into interstellar space. In either case, the orderly shell of satellites surrounding Earth would collapse into a chaotic spray of motion. This brings us to the ripple effect of gravity across the solar system. Earth is not just a passive passenger around the Sun. It is a participant in the gravitational fabric that binds everything together. Its presence slightly perturbs the orbits of Venus, Mars, and even distant Jupiter. With Earth gone, those perturbations disappear, and the orbits of other planets subtly adjust. Again, the changes are not catastrophic, but over thousands and millions of years, those tiny differences accumulate, altering alignments and resonances that have persisted for eons. For example, the delicate gravitational relationship between Earth and Venus, which helps maintain a certain balance in their orbital dance, is broken. Venus no longer feels Earth's pull, and over vast timescales, its orbit may shift in ways we can't fully predict. Mars, too, loses the faint but constant tug of its blue neighbor. Even asteroids in the belt between Mars and Jupiter would feel the difference, as Earth's gravitational influence, however small, once contributed to the overall distribution of their motions. The absence of Earth's pull changes the entire pattern ever so slightly, like removing one instrument from a symphony. On larger scales, the loss of Earth's gravity also affects objects we rarely think about, near-Earth asteroids and comets. Many of these bodies are subtly nudged by Earth's presence as they pass through the inner solar system. Without Earth there to bend their trajectories, their long-term paths take new forms. Some that might have been captured into Earth crossing orbits instead wander elsewhere, while others drift on unimpeded, changing the cosmic choreography in ways no human would ever be around to observe. The effects, then, are both immediate and long-term. Immediately, the Moon is set free, satellites vanish, and the Sun's gravitational wobble adjusts. Over time, the orbits of neighboring planets and asteroids evolve into new configurations, reshaping the solar system in quiet but profound ways. What looks like stillness from afar is, in truth, the beginning of a slow cascade of changes that could, millions of years later, create a solar system unrecognizable to us. And yet, even as these mechanical consequences unfold, something deeper lingers. The vanishing of Earth is not just a matter of gravity and orbital shifts. It is the removal of meaning in a cosmic structure that has, until now, included us. For the Moon, it means the loss of its eternal partner. For the Sun, a barely noticeable shift in its balance. For the planets, a new set of paths to follow. And for the solar system as a whole, it means the beginning of a new chapter written in silence, where the absence of Earth becomes one of its defining features. The physics of Earth's vanishing may be cold and mechanical, but what gives this scenario its true weight is not orbital mechanics or gravitational shifts. It is life itself. Every calculation, every subtle change in the solar system pales in comparison to the sheer magnitude of what it means for Earth to vanish, because Earth is not simply a lump of rock circling the Sun. It is alive. It carries forests, oceans, rivers, skies filled with birds, lands filled with animals, and above all, billions of human beings, each living their own story. To imagine Earth vanishing is to imagine all of that life ceasing in the same instant, without warning and without even the chance to understand what has happened. The brutality of this cannot be softened. If Earth disappears, so do we. There is no time to react, no time to resist, no opportunity to survive. One moment you are reaching for a cup of coffee, the next you are gone. A child in the middle of laughter, a doctor delivering a baby, a farmer walking through a field. all erased as if they had never been. Every living creature, from the smallest insect to the largest whale, ceases to exist in the same second. The suddenness is perhaps the most horrifying element of all. Death usually comes with process, with warning, with decay, with struggle. Here there is no process, only instant erasure. If you pause for a moment and imagine it personally, the weight becomes unbearable. Picture billions of simultaneous interruptions of thought and feeling. Someone composing music, someone whispering words of love, someone standing in silence watching the stars. These moments, rich and fragile, are cut off midstream. The music never finishes, the love never reaches its echo, the stars are swallowed by nothing. Human beings, who measure their lives in memories and stories, would leave behind neither. There would be no last chapter, no farewell, no collective closing of eyes. Only silence. The emotional scale of this thought is almost beyond human comprehension. Tragedies that scar our history, wars, disasters, plagues, are immense, yet they always leave survivors. They leave ruins that tell a story, graves that testify that someone once lived. In the case of Earth's vanishing, even that is denied. There is no record, no ruin, no echo. The Holocaust, the Black Death, the bombings of Hiroshima and Nagasaki, all left evidence, and through that evidence we remember. But here, remembrance itself is denied. It is not only life that ends, it is memory, history, and culture. Think of the libraries that have accumulated through centuries. The scrolls of Alexandria, once lost to fire, would pale in comparison to this loss. Every book, every record, every digital archive vanishes. The collected knowledge of humanity, from Newton's equations to Shakespeare's poetry, is obliterated in an instant. The paintings of Da Vinci, the sculptures of Michelangelo, the songs of countless traditions, the films, the photographs, the languages themselves, all gone as if they were never created. Art does not just disappear. It never existed in the eyes of the universe. And it isn't just the great monuments of culture that vanish, but the ordinary, intimate things. Family photographs tucked away in drawers. Journals scribbled with private thoughts. A child's crayon drawing taped to a refrigerator. These small tokens of existence, perhaps more representative of life than any grand monument, vanish too. The deeply personal proof of our being is erased along with the collective. Without Earth, the very idea of heritage collapses, because there is no vessel left to hold it. What deepens the weight of this loss is that Earth is, as far as we know, the only place where life exists. The universe is vast, and while we suspect there may be other forms of life somewhere among the billions of stars, we have no evidence of it yet. Earth is unique to us, the singular cradle of consciousness we have ever encountered. Its disappearance is not just a tragedy for humanity, but potentially a cosmic tragedy, the extinguishing of one of the rare sparks of awareness in an otherwise indifferent void. If life elsewhere exists, it has no way of knowing what has just been lost. If life elsewhere does not exist, then the universe becomes emptier in a way that cannot be measured. This annihilation of life also reveals something about how fragile our existence truly is. We tend to think of humanity as resilient, enduring, capable of surviving disasters. And it's true, we've weathered ice ages, meteors, plagues, and wars. But the vanishing of Earth demonstrates that our resilience is only as strong as the ground beneath us. Take that away, and there is nothing left. Humanity is not destroyed by its own failings or by some external catastrophe. It is simply erased along with the world that sustained it. From an emotional perspective, it is difficult not to dwell on the abruptness. Imagine someone mid-embrace, holding another in a moment of warmth, only to disappear before the embrace is complete. Imagine lovers separated by distance, waiting for the day they will meet again, only to find that day erased before it arrives. Imagine a child on the verge of speaking their first word, and that word never being uttered. These are the human scales of the tragedy, far removed from the calculations of physics, yet far more devastating. In trying to confront this scenario, one is forced to realize that culture, everything we value as a species, relies utterly on continuity. We hand knowledge down from one generation to the next, we build upon what came before, and we trust that the future will inherit what we leave behind. The vanishing of Earth is the shattering of that chain. It is not merely the silencing of one generation, but of all generations past and future. Every sacrifice made, every achievement won, every dream imagined, is wiped away, as though the universe pressed a reset button. If we linger here, we might also see how such a thought experiment reshapes our perspective on the present. To imagine Earth vanishing is to confront the fragility of everything we take for granted. We often argue over politics, power, and possessions, but those things would mean nothing in the face of instant erasure. In that light, the true treasures of existence, the ability to love, to create, to remember, stand out starkly. By imagining their loss, we are reminded of their value. And yet, even this act of imagining is paradoxical. If Earth vanished, there would be no one left to feel the loss, no one left to grieve, no one left to tell the story. The tragedy exists only in our speculation. The universe itself is indifferent. It would register Earth's absence as a mathematical adjustment in gravity, nothing more. It is only consciousness, ours, that gives the event weight. And so, in imagining this scenario, we create a ghost story of sorts, a narrative of loss that no one would be left to tell, but which we tell now because we can. In the end, the vanishing of life from Earth is the most profound consequence of this thought experiment. The moon may drift, the planets may shift, but nothing compares to the silencing of billions of voices in mid-sentence, the erasure of cultures in mid-story, the extinguishing of a spark that may be rare, even unique, in the universe. To think about it is to feel a heaviness, a recognition of how much is carried within this one small planet, and how easily it could, in imagination if not in reality, be erased. Though Earth itself and all life upon it vanish in an instant, not everything tied to humanity disappears with it. The planet may be erased, along with its atmosphere, its people, and all satellites in orbit, but there are fragments of our presence scattered farther out in the cosmos, fragments that do not depend on Earth to exist. These fragments, drifting silently through the void, become the only testimony that humanity ever lived. In a strange way, the human story does not end entirely with Earth's vanishing. It leaves behind a faint legacy, one so small compared to the scale of the loss that it seems fragile, almost ghost-like, yet it endures. The most tangible of these remnants are the spacecraft we have launched beyond the grip of Earth's gravity. The Voyager probes, launched in the 1970s, continue their slow journey outward, each carrying a golden record engraved with sounds and images of Earth. Beethoven's music, greetings in multiple languages, a child's laugh, all encoded into a disk meant to serve as a time capsule for alien discoverers. With Earth gone, those golden records become far more poignant. No longer are they a message from a living civilization. They are relics of a world that has ceased to exist. If someday an extraterrestrial intelligence were to find them, they would encounter voices from a planet that is no longer there, an echo of a species erased before its words could ever reach the stars. Alongside Voyager are the Pioneer spacecraft, each bearing a plaque etched with the figures of a man and a woman, the map of pulsars to locate our solar system, and the outline of the spacecraft itself. These, too, continue their outward flight, silent messengers from a civilization that left no home behind. To an alien eye, the information on those plaques may one day appear as evidence of an intelligent race. But with Earth gone, that evidence points only to absence. They will search for the home described and find nothing but empty space where Earth should have been. Then there are the New Horizons probe, which once revealed Pluto's icy heart, and other missions still drifting in the outer solar system. Each of them is now transformed from scientific tools into ghost vessels, forever separated from the species that built them. What was once a triumph of exploration becomes, in this scenario, a reminder of extinction. And yet, not all traces of humanity are physical. Even more intriguing, and perhaps more enduring, are the radio waves we have been transmitting into space for more than a century. From the earliest days of broadcast radio and television to modern satellite communications, Earth has been leaking electromagnetic signals into the cosmos like a lighthouse on a dark shore. These signals spread outward at the speed of light, forming an ever-expanding sphere now more than 100 light-years across. Within that bubble lies the invisible history of our technological civilization. An alien civilization with sensitive instruments might one day detect the faint pulses of our presence, the crackling of old radio shows, the static of news broadcasts, the faint hum of television signals. They would not be crisp or clear. Over interstellar distances, signals degrade and blend into the noise of the universe. Yet the signature of intelligence can still be extracted. Patterns emerge where randomness should reign. Structured pulses betray design. In that way, our civilization has already announced itself to the stars, even if unintentionally. Now imagine the irony. If Earth were to vanish tomorrow, those signals would continue their outward journey, carrying the story of a species that no longer exists. To any distant civilization that intercepts them, humanity would seem alive, broadcasting, thriving on a planet called Earth. They would have no way of knowing that by the time the signals reach them, the source has already disappeared. In effect, we would become a ghost civilization, projecting vitality long after our extinction. Our presence would live on not in reality, but in echoes of electromagnetic radiation spreading endlessly into the dark. This raises a haunting question. Would other civilizations ever detect our absence? To notice a disappearance requires first noticing a presence. Most of our signals are too faint to travel more than a few dozen light-years before blending into background noise. Beyond that distance, only the most powerful and intentional transmissions, such as radar pings aimed at planets, might stand out. If an alien intelligence lives within that expanding bubble, they may have already detected us, at least faintly. They might chart our location, calculate where Earth should be, and, if they someday turn their telescopes toward our solar system, they would find a puzzle. What would they see? The Sun, burning as always. Jupiter, Saturn, Mars, and the others still orbiting. The Moon, now drifting independently. But where Earth should be, nothing. To them, it would appear as though the very planet that broadcast those signals had vanished. They might assume catastrophe. They might wonder whether our species destroyed its own home, or whether some larger cosmic event intervened. They would never know the truth, only that the evidence points to a civilization that once existed but now has no world to inhabit. If their curiosity drives them far enough, if they send probes or even themselves across the stars, they may one day encounter Voyager, Pioneer, or New Horizons. They may piece together fragments of who we were, the music, the diagrams, the laughter of a child. And yet the context would be missing. No cities to visit, no ruins to study, no descendants to speak with. Only scattered clues, disconnected from the home they once represented. To them, humanity would be a riddle without a solution. This thought alone highlights something profound about legacy. We often think of legacy as what we leave behind for our descendants, the continuity of culture and memory across generations. But in the vanishing of Earth, there are no descendants. There is no one left to inherit, no one to tell the story. Our legacy becomes something different, a faint whisper left for strangers we will never meet, carried not by memory but by physics, etched into metal and encoded in waves of light. Yet even this legacy is fragile. Spacecraft are tiny against the immensity of the cosmos. Over millions of years, radiation, collisions with dust, and gravitational influences may degrade or destroy them. Radio signals, too, weaken with distance until they are indistinguishable from background noise. It is entirely possible that no one ever finds these fragments. Humanity's last traces may dissolve into silence, swallowed by the enormity of space. In that case, our existence would vanish not only in reality but in record, leaving the universe no sign that we were ever here. Still, there is something poignant in imagining that faint chance, that somewhere, sometime, another intelligence might stumble upon a fragment of us. They may hear a melody carried on a golden record, or decode a faint pulse of structured radiation, and wonder about the beings who created it. They may never know our fate, but they will know that, for a brief moment, we existed. And in that knowledge, fragile as it is, lies the closest thing to immortality our species could have in the face of such erasure. And this realization draws us seamlessly back toward the human dimension. Earth's vanishing is not only a story of what is lost, but of what lingers, however tenuously. The legacy of humanity, scattered among the stars, is both haunting and hopeful. Haunting, because it represents a civilization cut off mid-sentence, its story incomplete. Hopeful, because even in extinction, there is the possibility that we leave behind a trace, a memory, a sign that for a fleeting moment, the universe contained us. The absence of Earth is not a quiet subtraction, even if it begins as one. While the disappearance leaves no debris, no explosion, and no sound, its absence echoes in a different way, through the subtle rearrangement of gravity across the solar system. Gravity is not static. It is the constant dialogue between bodies, pulling and shaping, holding together the fragile harmony of orbits. Remove one planet, and the entire chorus must retune itself. The space where Earth once circled the Sun becomes a void, not in the sense of emptiness alone, but in the sense of influence, a gravitational hole where balance once existed. This gravitational void is perhaps best understood by imagining Earth as a dancer in a cosmic performance. Each planet contributes its weight and movement, and together they form the rhythm of the solar system. Earth's mass, while small compared to Jupiter or the Sun, played a role in keeping that rhythm. With its sudden disappearance, the choreography falters. The pull Earth once exerted vanishes instantly, and the nearby dancers, Venus and Mars, are the first to feel the change. For Venus, which orbits closer to the Sun, Earth's presence was not dominant but still significant. Over billions of years, Earth and Venus have influenced one another subtly, nudging each other's orbits in ways that kept a delicate balance. Without Earth, Venus loses that familiar tug. Its orbit, once stabilized by the interplay, begins to drift ever so slightly. Not in a dramatic lurch, the Sun still holds Venus firmly, but in a quiet shift that compounds over time. A fraction of a degree here, a tiny alteration in orbital eccentricity there. It's the kind of change that would be invisible in a single lifetime, but undeniable over millions of years. Mars, sitting just beyond Earth, feels an even greater loss. Earth's gravitational pull acted like a tether, a constant influence that helped shape Mars' long-term trajectory. With that tether cut, Mars becomes slightly freer, its orbit adjusting in ways that may seem insignificant at first, but can amplify as centuries stretch into millennia. The tiny variations in orbital speed and position build upon themselves, and though Mars will not suddenly spin out of control, its path gradually diverges from what it would have been. These changes ripple outward to the asteroid belt. Earth, though not nearly as massive as Jupiter, has played a quiet role in shaping the lives of asteroids through gravitational interactions. When asteroids pass near Earth, its pull alters their courses, sometimes drawing them into Earth-crossing paths, sometimes flinging them into new trajectories. Over the vast expanse of time, these interactions sculpt patterns, resonances that give the asteroid belt its current structure. With Earth gone, that sculpting hand is no longer there. The absence reshapes the probabilities. Near-Earth asteroids, which once faced capture or collision with our planet, now slip past into altered courses, their paths redirected by the Sun alone or influenced by Mars and Venus instead. Over thousands of years, this creates a belt that looks subtly different, a shifting mosaic of rock and metal whose balance has been quietly rewritten. The gaps and clusters in the asteroid distribution, once partly defined by Earth's presence, begin to take on new patterns. To future observers, it would appear as though some hidden influence had once been there, removed in a way that left faint fingerprints across the belt. And then there is Jupiter, the giant that dominates the solar system with its immense gravity. While Earth's mass is negligible compared to Jupiter's, the web of gravitational relationships is more complex than size alone. Earth's position between Venus, Mars, and the asteroid belt acted as a buffer, a stabilizing influence in the intricate balance of orbital resonances that ripple outward from the Sun remove Earth, and those resonances shift. The gravitational conversation between Jupiter and the inner planets now takes on a slightly different tone, one that grows louder as time passes. In the short term, Jupiter continues undisturbed. Its storms rage on, its moons circle as always. But in the long term, the absence of Earth's influence allows small imbalances to accumulate. Mars, no longer constrained by Earth's subtle pull, may fall more readily under Jupiter's influence. The asteroid belt, already dominated by Jupiter's gravity, becomes even more responsive to its massive tug. This could lead to more frequent perturbations, sending asteroids onto new, more chaotic paths through the inner solar system. Without Earth to counteract or absorb some of these influences, the long-term stability of nearby bodies is weakened. The cumulative effect is not immediate destruction, but slow destabilization. Over tens of millions of years, Venus' orbit could shift enough to alter its resonances with Mercury and Mars. Mars itself, already on a slightly eccentric path, might experience amplified variations. Asteroids that might once have been nudged into relatively safe orbits by Earth's gravity now find themselves drawn into riskier paths, with some potentially colliding with Mars or Venus, or being ejected from the solar system entirely. Jupiter's immense pull ensures that the overall balance is maintained, but it is a harsher balance, one less forgiving without Earth's quiet hand in the mix. What is fascinating about this cascade is how it highlights Earth's role not only as a home for life, but as a stabilizing agent in a cosmic system. We tend to see Earth only in relation to ourselves, yet its disappearance reveals how deeply interwoven it is with the mechanics of the entire solar family. Even though Earth is small compared to Jupiter and the Sun, its presence mattered. It shaped the paths of neighbors, influenced the flow of asteroids, and contributed to the fragile equilibrium that has persisted for billions of years. As time stretches forward, the absence of Earth may lead to a solar system subtly redefined. Mars and Venus, pulled into new rhythms, alter their long-term relationship with the Sun. The asteroid belt, reshaped by different resonances, becomes a more chaotic place, a field of wandering rocks less constrained than before. Jupiter, always the giant, exerts its dominance with fewer checks. The harmony of the solar system does not collapse, but it changes tune, and the new melody may sound harsher, more unstable, in the ages to come. And yet, even as these vast mechanical shifts unfold, they point us back to the deeper truth. Earth's significance lies not only in what it hosted, but in how it belonged. Its disappearance is not just the loss of a home, nor just the end of life. It is the unraveling of a balance that once defined our corner of the cosmos. The gravitational void left behind is more than empty space. It is a silence in the music of the spheres, one that reverberates through Venus, Mars, the asteroids, and Jupiter, rewriting their futures in subtle, inexorable ways. The Moon, for billions of years, has been Earth's companion, locked in a gravitational embrace that shaped both worlds. Its tides sculpted our oceans, its pull slowed Earth's rotation, and its presence stabilized our planet's tilt, keeping our climate within the bounds that allowed life to flourish. Yet, if Earth were to vanish tomorrow, the Moon would find itself abruptly released from that bond, cut loose from the gravitational tether that defined its entire existence. In that moment, it would cease to be a moon in the strict sense of the word, for a moon cannot exist without its parent world. It would instead become something else entirely, a wandering body with a destiny determined not by loyalty, but by chance and celestial mechanics. To understand what becomes of the Moon in such a scenario, it helps to consider its state at the instant Earth disappears. The Moon orbits Earth at an average distance of about 384,000 kilometers, circling once every 27 days. That motion is not random. It is the balance between the Moon's forward velocity and the inward pull of Earth's gravity. Remove Earth, and that pull vanishes instantly. The Moon's forward velocity, however, does not vanish. In that instant, it is as though the leash is cut while the runner is still moving at full speed. The Moon continues on, no longer curved into a circle by Earth's grip, but instead flying free into a new trajectory. That trajectory, crucially, is not determined by emptiness but by the Sun. For in truth, both Earth and the Moon have always been orbiting the Sun together, with Earth's gravity merely keeping the Moon bound in a secondary loop around it. Without Earth, the Moon continues in the same general direction it was already moving, but instead of spiraling around Earth, it begins tracing its own path around the Sun effectively. The Moon becomes a small planet in its own right, following an orbit very similar to Earth's, at least initially. This raises the first possible outcome. The Moon becomes a minor planet, an object orbiting the Sun independently, much like an oversized asteroid or dwarf planet. Its orbit, at least in the beginning, would nearly match Earth's former orbit, since the Moon had been sharing Earth's journey around the Sun all along. For a time, it would look as though Earth had been replaced by a smaller, dimmer, and lonelier traveler, a ghostly reminder of what was lost. But such an arrangement cannot last unchanged. Without Earth's mass to stabilize its orbit, the Moon would gradually begin to drift. Interactions with Venus, Mars, and even the asteroid belt would alter its trajectory over thousands of years. Another outcome, less stable but equally possible, is that the Moon could be pulled off its near-Earth orbit and fall gradually toward the Sun. The Moon does not suddenly plummet inward. It is still moving fast enough to remain in orbit around the Sun, but small gravitational nudges from other planets, especially Venus and Jupiter, could over long spans of time shift its orbit inward. If this happens, the Moon might eventually become a doomed wanderer, spiraling closer to the Sun until it is destroyed, its surface baked and torn apart by solar radiation and tidal stresses. In such a fate, the Moon would be swallowed not by earthly tides, as it once controlled, but by the star that had always dominated the system. Yet there is another intriguing possibility: capture. Without Earth to anchor it, the Moon is vulnerable to the gravitational pull of its neighbors. Mars, though smaller, is close enough that under the right conditions it could snag the Moon, transforming it into an oversized satellite. Imagine the Martian sky with a colossal Moon rising above its deserts, a celestial prize adopted from its missing sibling world. More likely, however, Jupiter would be the ultimate captor. With its immense gravity and history of gathering a retinue of dozens of moons, Jupiter could easily sweep the Earth's lost moon into its collection. There it would join Europa, Ganymede, and Callisto, becoming another jewel orbiting the gas giant, a displaced reminder of Earth's vanished presence. Of course, capture is not guaranteed. For many wandering bodies, especially those with initial velocities like the Moon's, gravitational interactions are more likely to sling them away rather than hold them. In that case, the Moon might be ejected from the solar system entirely. Flung out by Jupiter's gravity or nudged by a sequence of planetary encounters, it could be cast into interstellar space, a rogue moon traveling alone between the stars. In that endless darkness, the Moon would carry with it the scars of its history, its craters, its basalt plains, its silent testimony to a planet and a people that once were. The fate of the Moon also has implications for nearby bodies. If it remained in a sunbound orbit near where Earth once traveled, it would interact gravitationally with Venus and Mars. These encounters could subtly alter their paths, just as Earth once influenced theirs. Over long timescales, such interactions might destabilize resonances, leading to shifts in orbital patterns. The asteroid belt, too, would feel the Moon's presence, or rather, the absence of Earth's shielding role. Without Earth to serve as a gravitational filter, the Moon alone would lack the mass to alter many incoming asteroids. Still, its wandering path could occasionally perturb smaller bodies, creating ripples of change in a region already vulnerable to Jupiter's dominance. Even in the scenario where the Moon is ejected entirely, the effects linger. Its absence means one less gravitational participant in the solar system's delicate balance, and though its mass is small compared to the planets, the accumulated influence over millions of years would no longer be felt. Just as Earth's disappearance destabilizes the harmony, so too does the Moon's absence shift the music, even if only by a note. Perhaps the most haunting aspect of the Moon's fate is the symbolism of its freedom. For so long, it was tied to Earth in a relationship that shaped both bodies. The Moon pulled Earth's oceans, guided its nights, and slowed its spin, while Earth sheltered the Moon in orbit, preventing it from drifting aimlessly. Their partnership was more than proximity. It was a bond. With Earth gone, the Moon becomes untethered, unmoored, and adrift in a cosmos that shows little mercy to solitary wanderers. Whether it ends as a new planet, a captive of Jupiter, or a rogue object lost to interstellar space, the Moon's new destiny unders the fragility of cosmic companionship. And in this strange irony, the Moon may end up being the last trace of Earth that remains visible to the rest of the solar system. Other planets, looking across the void where Earth once circled, might still see the Moon moving along the old path for some time. Like a lone survivor circling a battlefield, it would stand as a mute witness to the loss of its parent world. To alien astronomers far away, the disappearance of Earth might not be immediately obvious. What they would see, at least for a while, is a smaller body tracing a familiar orbit, a puzzle to be solved only by the slow realization that a greater planet is missing. The Moon's journey after Earth's vanishing is thus a story of transition, from Moon to orphan, from companion to wanderer, from a stabilizer of life to a symbol of solitude. In its new path, wherever that path leads, it carries with it the silent memory of Earth, not only as its parent world, but as the anchor of an entire chapter in cosmic history. Its future is uncertain, but its role as Earth's final legacy is undeniable. When the Moon's uncertain trajectory has finally settled, whether it drifts into the inner solar system or is flung toward the void, the focus inevitably turns back toward the central star. The Sun, after all, is the anchor of everything, the massive gravitational engine that dictates the movement of every planet, asteroid, and comet. With Earth gone, the question becomes not only what happens to its nearest companions, but also how the Sun itself feels the loss. To an outside observer, this might sound like an overstatement. How could the disappearance of a single planet, tiny compared to the star, really matter? But in the mechanics of celestial balance, even small absences ripple outward in subtle yet undeniable ways. The most immediate truth is that the Sun would notice little in the short term. Earth's mass is about 1/3 millionth that of the Sun, an amount far too small to tug on the star in any significant way. If the solar system were imagined as a grand dance, Earth's absence would be like one dancer stepping out from the edge of a wide circle. The center figure keeps moving almost the same, the music unchanged, the rhythm steady. Yet that doesn't mean the choreography is identical. Over longer periods, the missing partner shifts the way the remaining dancers interact, and the rhythm of their steps begins to drift. Part of this change lies in the solar system's barycenter, the true center of mass around which all objects, including the Sun, actually orbit. It is often surprising to realize that the Sun does not sit perfectly still in the middle, but rather wobbles around depending on the pull of its planets, especially Jupiter, whose massive weight dominates the balance. Earth, although small compared to Jupiter, still contributes a measurable nudge. Without it, the solar system's center of mass shifts ever so slightly inward, changing the Sun's tiny orbital wobble. The adjustment is subtle, amounting to a displacement of only a few hundred kilometers, but for a system measured in billions of kilometers, even this difference can alter the long-term mathematics of orbital resonance. Those resonances are where the absence of Earth becomes more consequential. Earth participates in delicate gravitational relationships with its neighbors. With Venus, there exists a near 13:8 resonance, a rhythm in which their alignments repeat in predictable patterns. With Mars, another subtle interplay helps maintain the red planet's stability. These resonances act like invisible scaffolding that supports the solar system's harmony. Remove Earth, and those scaffolds weaken. Venus may find itself slowly drifting into new orbital rhythms, while Mars might experience small but accumulating deviations in its path. Such changes would not unfold in days or years, but over millions of years, tiny shifts could blossom into dramatic reorganizations. For the Sun, this means a gradual rebalancing of the angular momentum distributed among its planets. Angular momentum is conserved across the solar system, like money in a shared account. When one contributor vanishes, the remaining balances adjust. Jupiter, Saturn, and the other giants would still dominate, but the careful sharing of momentum that has kept orbits steady for billions of years would now lean in slightly different directions. Over immense stretches of time, this could make the solar system more chaotic, pushing planets into new positions or increasing the chances of collisions among smaller bodies. The absence of Earth also removes its unique gravitational influence on countless smaller objects. Earth is a key player in shepherding near-Earth asteroids, nudging them through resonances and sometimes capturing them into temporary orbits before releasing them again. Without this influence, the Sun's gravitational field still governs the motion of those objects, but the pathways they follow become less constrained. Some might spiral more easily into the inner solar system, altering the frequency with which they graze Venus or even fall into the Sun. Others might drift outward, pulled into the greater gravitational arms of Jupiter. In this way, Earth's absence indirectly reshapes how the Sun feeds on material, either through impacts or through altered streams of dust and debris. Even the faint zodiacal cloud of dust that spreads throughout the inner solar system would change. Much of this dust is continually replenished by asteroids and comets, but Earth plays a role in sweeping and scattering it. With no Earth to stir these fine grains, the patterns of light scattering in the Sun's vicinity would subtly shift. To a human observer, had there been one, the night sky viewed from Mars or Venus would no longer carry the same soft glow of zodiacal light. The Sun would shine through a slightly different veil of dust, its environment perceptibly altered. For astronomers far beyond our system, Earth's disappearance would be even more conspicuous. When distant observers study stars, they often detect planets by the way those planets dim the starlight during transits. Earth has long offered such a predictable signature, a tiny but regular dip in brightness every year as it crosses the Sun's face from the proper vantage point. Suddenly, that dip would vanish. To those distant astronomers, it would be as if an entire world had winked out of existence. Moreover, the timing variations in the transits of Venus and Mars, normally influenced by Earth's pull, would also change. The Sun's symphony of dimmings and gravitational tugs would acquire a new rhythm, one missing a key instrument. From the Sun's own perspective, though, none of this would alter its internal life. Nuclear fusion would continue in its core, churning out light and heat just as before. The stream of solar wind would remain unchanged, sweeping across the solar system. But the way this energy interacts with its environment would now differ. The missing magnetic shield of Earth means more solar particles would continue unhindered, impacting Mars and Venus more strongly, altering their upper atmospheres. The Sun's influence, unchecked by Earth's protective barrier, would feel slightly different in its reach. These are not catastrophic shifts. The Sun has seen planets form, migrate, and vanish before. It is not a fragile system, but rather a dynamic one, resilient across cosmic ages. Still, the absence of Earth is more than a footnote. It introduces a new trajectory for the evolution of the solar system, a slow drift toward a different balance of orbits, collisions, and resonances. Over hundreds of millions of years, that drift could mean Venus spiraling closer to the Sun, Mars wandering into greater eccentricity, or the asteroid belt scattering in less predictable patterns. Each of these changes, though subtle, begins with the empty space Earth once filled. From the fate of the Moon to the quiet adjustments of the Sun, the disappearance of Earth reshapes the system in ways both immediate and timeless. And yet, as much as these gravitational ripples matter, the solar system remains in motion, carrying on its endless cycles. The story does not end with the Sun's rebalancing. It extends outward, where the absence of Earth reverberates into the greater architecture of the cosmos itself. With Earth gone and the Moon drifting untethered, the solar system would enter a state of subtle imbalance. While the immediate effect on the Sun is minimal, as previously discussed, the broader consequences manifest as ripples through the gravitational web that binds the system together. Gravity is not instantaneous, but its influence propagates according to well-understood physics. Even the disappearance of a relatively small planet like Earth creates a shift that could, in principle, be measured, though only with extraordinarily precise instruments. This is where the notion of cosmic ripples begins to take shape, a cascade of perturbations traveling outward, invisible to the naked eye, yet present in the motion of all nearby bodies. The first point to consider is the effect on the solar system itself. When Earth vanishes, the gravitational pull it exerted on its neighbors disappears simultaneously. Mars and Venus, whose orbits are partially shaped by Earth's presence, adjust ever so slightly in response. The Moon, now freed, traces a new path, exerting its own gravitational influence elsewhere. Even Jupiter, though dominant, experiences minuscule changes in the net forces acting on it. The combined result is a rearrangement of the gravitational balance, akin to plucking one string on a tightly tuned instrument. The whole symphony shifts subtly, though the dominant notes remain. Could this gravitational shift be detected beyond our solar system? In theory, yes. Alien civilizations with sufficiently advanced instruments could measure the movement of stars with extreme precision, detecting the tiniest perturbations in stellar motion. Astronomers today already do this using methods like radial velocity measurements, which detect the slight wobble of a star caused by orbiting planets. Earth's disappearance would remove its contribution to the Sun's motion, reducing the amplitude of the Sun's wobble by a minuscule fraction. To a civilization watching from light years away, this sudden disappearance might appear as a tiny anomaly in the star's motion, an unexpected adjustment in its gravitational profile. In practice, the signal would be extremely subtle. Earth's mass is tiny compared to the Sun and even Jupiter, so the change in the Sun's reflex motion is on the order of centimeters per second. Only civilizations with technology capable of measuring stellar velocities with exquisite precision could detect it. They would notice that one of the expected gravitational influences, the familiar periodic tug associated with an Earth-mass planet, is gone. This might raise questions, prompt recalculations, or inspire models of catastrophic loss, but it would not broadcast Earth's fate to the galaxy in dramatic fashion. Beyond gravitational influence, there is the question of whether the disappearance might create a detectable wave or shock. In Newtonian mechanics, gravitational effects are instantaneous, but in the framework of general relativity, changes in a mass distribution propagate at the speed of light. The removal of Earth could, therefore, be interpreted as sending a gravitational wave outward. The effect would be vanishingly small, far weaker than the cataclysmic mergers of black holes or neutron stars that contemporary instruments like LIGO can detect. Yet, in theory, a civilization with extraordinarily sensitive detectors might pick up the signal, recognizing it as the disappearance of a planet rather than a cosmic collision. For nearby planetary systems, these ripples would be entirely imperceptible. The gravitational tug of Earth on its solar neighbors is negligible at interstellar distances. Even the closest stars would feel no direct effect. The significance of Earth's vanishing would primarily manifest in the motions of bodies within its own system, cascading over millions of years through orbital shifts, asteroid trajectories, and perturbations in the Moon's path. These are not immediate shocks in the sense of visible disruptions. Rather, they are gradual adjustments, subtle changes that accumulate slowly, detectable only through precise measurement or simulation. Interestingly, the concept of gravitational ripple carries a dual meaning here. While there is the physical propagation of changes in the field, there is also the observational ripple, the way this event would appear to distant observers relying on indirect measurements. For civilizations watching the sun with advanced technology, the absence of Earth would manifest not as a bright flash or sudden disappearance, but as a missing periodic signal. Calculations of the sun's mass distribution, its orbital wobbles, and the expected positions of planets would all fail to align perfectly with models that assume Earth's presence. The result would be a subtle puzzle, a cosmic discrepancy demanding explanation. From the perspective of astronomers situated within our own galaxy, the disappearance of Earth might seem negligible. The motions of stars, the positions of distant exoplanets, and the light from far-off galaxies would remain unaffected. Only by focusing on the immediate vicinity of our Sun could an observer detect a discrepancy. This emphasizes a recurring theme in this thought experiment. Scale matters. On cosmic scales, the loss of one terrestrial planet is a tiny perturbation. On the scale of the solar system, however, it is significant, altering orbits, trajectories, and resonances. There is also a temporal element to consider. Gravitational effects propagate outward at the speed of light, and the Moon, now untethered, begins to influence nearby bodies over time. Mars and Venus gradually adjust their orbits in response to the combined absence of Earth's direct pull and the Moon's new trajectory. Over millions of years, these adjustments could produce detectable patterns. Slight increases in orbital eccentricity, minor shifts in orbital planes, or changes in asteroid belt distributions. Each is a ripple of consequence stemming from a single sudden absence. For alien civilizations attempting to model our system, these cumulative effects could be intriguing. They might detect the Moon's altered orbit, notice discrepancies in the inner planet's movements, and infer that a planet has vanished. This is particularly true if the civilization has a long-term observational record. Earth's disappearance would stand out not in dramatic cataclysm, but in the subtle divergence between prediction and observation. Models based on prior observations would suddenly fail, leaving clues that something unprecedented had occurred. Finally, it is worth noting that while the disappearance of Earth generates detectable ripples, it does so in a quiet, insidious manner. There are no explosions, no light shows, no cosmic fireworks. Instead, the event is recorded in the language of motion, the way the Moon curves differently, the way Mars shifts imperceptibly, the way the Sun's reflex motion diminishes. These ripples extend outward, a silent record of the vanishing, waiting to be decoded by those who know how to read them. The cosmic ripples, therefore, are both physical and observational. Within the solar system, they manifest as shifts in orbits, trajectories, and resonances, accumulating gradually over time. Beyond the solar system, they appear as anomalies in stellar motion, tiny absences in expected gravitational patterns, subtle deviations detectable only by highly advanced instruments. Together, they create a signature of Earth's erasure, a faint but persistent whisper that the planet once existed and now does not. Even when considered purely as a thought experiment, the idea of Earth vanishing sparks a profound psychological reaction. Humans are wired to imagine continuity, to see themselves as part of a chain that extends backward into history and forward into the future. The sudden removal of our planet, along with everyone on it, strikes at the very core of that instinct. Even when we understand intellectually that this scenario is impossible, or at least extraordinarily unlikely, the mind struggles to process the enormity of it. The first response is often disbelief, a refusal to accept that something so fundamental could be erased in an instant. Yet the imagination, once stirred, refuses to relent, and what follows is a cascade of emotional and cognitive consequences. At the most basic level, contemplating sudden extinction evokes fear, an immediate, visceral dread. Unlike the abstract anxiety we might feel about disease, war, or climate change, this is a fear of complete obliteration. There is no warning, no mitigation, no survival plan. The usual coping mechanisms, preparation, avoidance, or rationalization, fail entirely. The mind grasps at analogies, extinction events in Earth's past, the annihilation of civilizations, catastrophic asteroid impacts. But none of these truly capture the totality of being erased along with the planet itself. The result is a form of acute existential anxiety, one that challenges not only our sense of personal mortality, but the very notion that our species, or even reality as we know it, has a meaningful continuity. This fear is compounded by the notion of invisibility. To vanish without a trace is to be removed not only physically but culturally, historically, and conceptually. Human beings derive comfort and identity from the idea that they leave a legacy: children, achievements, art, records of existence. The idea that everything we know, everything we have built, could be wiped out in an instant, leaving no footprint at all, produces a unique strain of terror. It is a fear of erasure not just from physical space, but from memory, a complete severance from the cosmic ledger that records existence. No monuments, no descendants, no message carried forward, a total nullification. Philosophers and psychologists might label this the ultimate existential crisis. Unlike personal mortality, which can be absorbed into daily life, cultural continuity, or belief systems, planetary disappearance offers no framework for understanding or coping. Religions and philosophies often provide comfort through narratives of persistence, souls enduring, legacies continuing, nature regenerating. None of these mechanisms apply when the entire human project is instantly obliterated. The mind is confronted with the radical finality of nothingness, and this forces a confrontation with questions that are usually background. What is the purpose of existence if it can vanish entirely in an instant? What meaning can human life possess when its entire context, the Earth, is so fragile? In contemporary society, this scenario interacts with existing anxieties. We live with constant reminders of vulnerability: climate crises, nuclear weapons, pandemics. Imagining Earth disappearing amplifies these concerns to a cosmic scale. It is not merely a local disaster, but the ultimate disruption. Psychologically, this can provoke a sense of helplessness akin to learned helplessness observed in experimental psychology, where individuals exposed to uncontrollable events lose the motivation to act even in solvable situations. Faced with total extinction, our cognitive mechanisms cannot formulate a response, leaving only reflection, dread, and awe. Yet this thought experiment also illuminates resilience in the human psyche. Many individuals, when confronted with such impossibility, transition from fear to philosophical contemplation. The mind shifts from panic to abstraction, exploring the boundaries of existence, reality, and perception. Some engage in mental exercises of cosmic perspective, imagining the solar system from afar, or the universe as a theater indifferent to human presence. In this frame, personal and collective fear gives way to wonder, curiosity, and the recognition of scale. The paradox of being able to imagine total erasure, while simultaneously seeking patterns and continuity, reveals both the fragility and the adaptability of human consciousness. Another dimension is the confrontation with legacy. Humans are deeply invested in the idea that their actions, knowledge, and culture endure beyond their lifespan. Considering the total vanishing of Earth confronts us with a scenario where no legacy remains, where every book, painting, city, and child disappears. This heightens the awareness of mortality not just for individuals, but for civilization itself. It forces reflection on the impermanence of human endeavors and the limits of influence. This, in turn, fosters an awareness of how dependent meaning is on persistence. Without continuity, even the most significant achievements are rendered moot. Some psychologists argue that contemplating extreme existential scenarios can serve a protective function. By facing the possibility of total loss, humans may strengthen their cognitive and emotional resilience. Thinking through Earth's disappearance forces a confrontation with impermanence, uncertainty, and vulnerability in a controlled, abstract setting. It can lead to a deeper appreciation of life's fragility, motivating reflection on values, priorities, and the ways we interact with our environment and one another. Even in imagining nothingness, the mind finds opportunities to affirm meaning, however fleeting. Finally, the scenario underscores the universality of existential fear. Across cultures, humans grapple with questions of mortality, significance, and legacy. Earth's disappearance magnifies these concerns to a collective scale, demonstrating that our attachment to stability, continuity, and survival is not merely personal but species-wide. The psychological response encompasses terror, awe, contemplation, and eventual philosophical abstraction. It mirrors the human tendency to seek patterns, purpose, and connection even in the face of complete uncertainty. In essence, the mental experiment of Earth vanishing highlights the dual nature of human consciousness, our vulnerability to existential anxiety and our capacity for adaptive thought. We fear oblivion, yet we can reflect on it, theorize it, and even find meaning in the contemplation itself. The scenario crystallizes the delicate balance between fear and reflection, terror and curiosity, extinction and awareness. It is a reminder that human consciousness, while fragile, is capable of confronting the unimaginable and weaving it into the ongoing narrative of understanding. As the thought experiment unfolds, attention turns to humanity's outposts beyond Earth's surface, most immediately the International Space Station and any astronauts in orbit at the moment of disappearance. The ISS is a marvel of engineering, a symbol of human cooperation and scientific ambition, circling the planet at approximately 408 kilometers above the surface. It relies entirely on Earth's gravity to maintain its orbit, along with carefully timed thruster adjustments. In the instant that Earth vanishes, the situation becomes catastrophic in a way that is almost unimaginable. For if Earth itself ceases to exist, so too do the astronauts, engineers, and scientists who are considered part of this planet. Their existence is inseparable from the physical body of Earth. If the Earth is gone, they vanish as well, their physical form and presence erased alongside the planet that sustains them. However, for the sake of exploring the physics and broader consequences, let us imagine an alternative interpretation in which astronauts are somehow exempted from total annihilation, perhaps existing as isolated masses independent of Earth. In this scenario, the ISS, once anchored in orbit around the now absent Earth, loses the centripetal force that holds it in a circular path. Orbit is no longer possible without the gravitational pull of the planet below. In an instant, the station and its occupants are cast adrift, subject only to the Sun's gravity. They become tiny rogue objects in space, initially moving along trajectories tangent to their former orbits. The familiar round-the-Earth path is replaced by a long, elliptical orbit around the Sun, determined by their previous velocity and the gravitational influence of other nearby celestial bodies. This is a stark illustration of dependence. Every maneuver, every orbit, every systems check aboard the ISS is predicated on the Earth existing below. Without that anchor, everything loses meaning. The life support systems, designed to regulate air, temperature, and waste for humans in close orbit of a living planet, no longer serve their intended purpose. Communication with mission control becomes meaningless, as no control center exists to receive or transmit data. The symbolism of the station as a beacon of human exploration is shattered, not just physically but conceptually. What was once a testament to human ingenuity becomes an adrift relic, orbiting the sun in silence, a monument to a species that no longer exists. The trajectory of the ISS in this scenario depends heavily on the velocities at the moment of disappearance. Without Earth's pull, the station initially continues along the tangent of its last orbit, moving at approximately 7.66 kilometers per second. Over time, it begins to interact gravitationally with the Sun, as well as any nearby planets that pass within range. These interactions are weak but cumulative, slowly altering its path over months and years. Eventually, in many potential outcomes, the station could spiral closer to the Sun, drawn inward by the star's dominant gravity, or it could be perturbed into a slightly larger orbit, wandering indefinitely through the inner solar system. Either way, the orbital mechanics are starkly different from the familiar, predictable cycles that once made life in low Earth orbit sustainable. The astronauts themselves, in this hypothetical survival scenario, face an even harsher reality. Detached from Earth's protective magnetic field and atmosphere, they are exposed to the full intensity of solar radiation and cosmic rays. The station, designed to shield against normal levels of radiation, cannot compensate for the absence of Earth's geomagnetic protection. Additionally, without Earth's gravitational influence, microgravity conditions may become extreme, affecting the astronauts' physiology in ways that human bodies are unprepared to endure. Over time, muscle atrophy, bone loss, and other complications would accelerate, rendering survival increasingly unlikely. Beyond the immediate physical dangers, the psychological dimension is profound. Astronauts, trained to face adversity and isolated environments, would find themselves orbiting a universe that is both familiar and unrecognizable. Their entire conceptual framework, life support, mission protocols, communications, and the very planet they departed from, would be gone. The realization of total isolation, unbounded by Earth or any human presence, would compound the already extreme stress of their environment. It is not simply survival they face, but the existential weight of being utterly alone, witnessing the cosmos in which their home no longer exists. Even the symbolic implications are staggering. The ISS has long represented humanity's presence in space, a demonstration that we have extended our reach beyond the planet. Its orbit is a visible marker of exploration, progress, and ambition. With Earth gone, this marker loses context entirely. The station's silhouette against the sky, once emblematic of international cooperation and scientific achievement, becomes a ghostly relic drifting in a sun-centered orbit, devoid of observers or meaning. It is the ultimate closure of humanity's nascent steps into space. The physical manifestation of human ambition continues to move, but the consciousness and culture that gave it significance are erased. Similarly, other human-made satellites orbiting Earth face comparable fates. Communications satellites, weather monitors, and reconnaissance platforms, all dependent on Earth's gravity, would suddenly be released, their trajectories now determined solely by the Sun and by chance encounters with planets or the Moon if it still exists in an independent orbit. They, too, become adrift, traveling in isolation, no longer serving the purposes for which they were designed. The network of human technological presence that once encircled the planet dissolves into chaos, leaving behind scattered traces of a civilization that has ceased to exist. In terms of scientific observation, the absence of Earth and its orbiting technology is profound. Telescopes, monitoring instruments, and experimental platforms in low Earth orbit cease to function in any meaningful way. Experiments designed to study the planet, the atmosphere, or near-Earth phenomena lose their context entirely. Data streams vanish, measurements become irrelevant, and decades of accumulated scientific knowledge lose their connection to the very subject they were intended to study. The intellectual and symbolic threads linking humanity to the cosmos unravel alongside the physical disappearance. Ultimately, the fate of the ISS and any astronauts orbiting at the moment of disappearance reinforces the central theme of this thought experiment. Humanity's existence is inseparable from its planetary home. The physical, technological, psychological, and symbolic consequences converge to illustrate how dependent we are on Earth. Even our most ambitious ventures into space, remarkable though they are, rely entirely on the continued presence of the planet. Without it, the orbiting human footprint ceases to hold relevance, leaving behind only drifting artifacts in a vast, indifferent solar system. The scenario serves as a stark meditation on human vulnerability, technological reliance, and the fragility of our achievements. It emphasizes that exploration, survival, and legacy are contingent upon a stable home, and without that foundation, even the pinnacles of our ingenuity dissolve into silence. The ISS and its hypothetical occupants, once a testament to human potential, become spectral reminders of the scale and immediacy of Earth's importance, not just as a cradle of life, but as the anchor for every human endeavor in space. From the vantage point of a distant star system, the disappearance of Earth would be both subtle and extraordinary. Alien astronomers, equipped with technology advanced enough to detect exoplanets, rely primarily on indirect observations, the transit method, radial velocity measurements, and occasionally direct imaging. Each of these techniques depends on Earth existing to leave its mark. For instance, the transit method measures the tiny dip in a star's brightness when a planet crosses in front of it. For billions of years, Earth has produced a consistent, periodic dip in the sun's light, a faint but measurable signal that repeats once every 365.25 days. Its sudden disappearance would erase this signal entirely, leaving a peculiar void in what had been a predictable pattern. To an alien civilization monitoring the sun from light years away, this absence would register not as an explosion or flash, but as a missing signature in an otherwise rhythmic sequence. Observers accustomed to the periodic dimming associated with a planet of Earth's size would notice that one orbit suddenly appears empty. If they had decades or centuries of observational records, the change would stand out even more starkly. A previously consistent transit abruptly ceases. The pattern they had used to infer the presence of a habitable, life-bearing planet vanishes, leaving what could be interpreted as a ghost planet, a missing world that once existed but is no longer detectable. This phenomenon would likely provoke intense curiosity and speculation. Alien astronomers, noticing the absence, might attempt to reconcile their data with known physical laws. Perhaps they would first hypothesize that Earth had migrated closer to or farther from the Sun, or that an unobserved cataclysm had altered its orbit. They might consider explanations such as a collision with a massive object, planetary disintegration, or some form of cosmic intervention. Their models, built on centuries of careful observation, would no longer match reality, forcing them to confront a truly anomalous event. Direct imaging, if sufficiently advanced, would compound the mystery. The familiar blue dot that marked Earth in the visible spectrum would no longer appear against the backdrop of the Sun. In the absence of the planet, the system's light distribution changes subtly but measurably. While the Sun would remain its bright, central presence, one tiny point of reflected light, Earth's signature, would be gone. To an alien astronomer studying exoplanets for potential habitability, the sudden absence of a reflective, atmosphere-bearing planet might suggest rapid, catastrophic events, or even the intentional removal of a planet, raising questions about phenomena far beyond their current understanding. Radial velocity measurements would similarly reflect Earth's absence. The Sun experiences a tiny wobble as it responds to the gravitational pull of its planets. Earth contributes a minuscule but consistent component to this motion. Without Earth, the amplitude of this reflex motion decreases slightly, an alteration detectable only by the most sensitive instruments. For extraterrestrial scientists accustomed to precision data, this reduction in wobble would be puzzling. It would be evidence of a missing mass in a location where it had once been reliably inferred, confirming that something extraordinary had occurred in the system. The implications extend beyond mere detection. Alien astronomers would likely attempt to reconstruct the dynamics of the solar system, comparing historical data against present observations. The Moon's independent orbit, if it still exists, could serve as an additional clue. They might notice that a smaller, lone object follows an unexpected trajectory that does not conform to a standard planetary orbit. Without Earth to anchor it, the Moon's path may appear anomalous, potentially leading observers to conclude that a massive body once occupied its previous orbital space. In this way, the Moon itself becomes a silent witness to Earth's disappearance, a lingering signal in an otherwise puzzling void. The psychological and scientific response of such civilizations is an intriguing consideration. Like humans, they might experience a form of cosmic astonishment, a recognition that an entire planet, once observable and predictable, has vanished. Their theories of planetary formation, system stability, and life-bearing potential would all be challenged. They may also debate whether the disappearance is natural, accidental, or even deliberate, producing philosophical as well as scientific investigations. In essence, Earth's absence would become a compelling enigma, a puzzle whose solution could redefine their understanding of astrophysics, planetary science, and potentially the fragility of life-bearing worlds. Over time, the anomaly would propagate through the galaxy via light and observation. Any civilization cataloging exoplanets would note the missing transit and its associated gravitational signature. Future generations of alien astronomers, with records extending back centuries, would be able to pinpoint the moment when the ghost planet ceased to exist. Earth's vanishing, though physically instantaneous, becomes a temporal signal that echoes across the cosmos in the data recorded by distant eyes. Even without direct observation, the ripple of absence spreads outward, detectable as a discontinuity in the otherwise regular architecture of the solar system. From a human perspective, this scenario underscores the fragility of planetary existence. What seems permanent, Earth as a blue, living in the Sun's orbit, is, in cosmic terms, ephemeral. The same observation techniques used to search for life elsewhere could, if Earth were gone, reveal our sudden absence, making humanity's disappearance a detectable event to others. In this sense, the universe holds a kind of impartial witness, one that records not just what exists, but also what no longer does. The ghost planet mystery is both a scientific puzzle and a silent memorial, a signal that something once thriving has vanished from the galactic ledger. The absence of Earth also illustrates the limits of perception. Distant civilizations would see only the consequences, the missing transit, the altered radial velocity, the Moon adrift, but they would not perceive the moment of disappearance itself. The event, instantaneous at the scale of the solar system, is invisible in real time across light years. They would reconstruct its occurrence retrospectively, piecing together evidence over decades or centuries, much like archaeologists reconstruct the history of a civilization from ruins. In this way, Earth's existence and sudden absence become simultaneously real and theoretical, a cosmic riddle for observers across the void. Finally, the notion of a ghost planet underscores the unique position Earth occupies in the galaxy. From afar, it is detectable as a rare, habitable world, rich with biosignatures, atmosphere, and oceans. Its disappearance is both scientifically measurable and conceptually jarring, emphasizing how a single terrestrial planet can register across light years, leaving an observable imprint on distant astronomers' instruments. The mystery of its vanishing is not simply a question of physics, but a meditation on presence, absence, and the detectability of life itself. At the heart of contemplating Earth's sudden disappearance lies a profound philosophical question. What is the meaning of existence if it can be erased in an instant? Humans have long operated under the assumption that the world, the planet we inhabit, and the structures of civilization will persist beyond the lifespan of individuals. Our philosophies, religions, and scientific endeavors are all built on a foundation of continuity, however tentative that continuity may actually be. We plan for generations, record knowledge, and build monuments because we expect some form of permanence. But imagining the immediate vanishing of Earth challenges this assumption completely, revealing the fragility not only of life but of the very frameworks we use to ascribe meaning to existence. This thought experiment confronts humanity with an uncomfortable truth. Permanence is an illusion. No matter how advanced our technology or how carefully we document our civilization, the physical reality of Earth and all it contains can, hypothetically, cease to exist without warning. This exposes a stark contrast between human perception and cosmic reality. While we experience time in decades and centuries, the universe operates on scales of millions and billions of years, indifferent to our narratives. The philosophical implication is that meaning cannot be intrinsic to permanence. Instead, it must be constructed, experienced, and understood within the fleeting moments of existence. Our lives, our cultures, and our achievements are inherently temporal, and their value does not derive from their inevitability, but from the presence, awareness, and recognition that accompanies them. Humanity's obsession with permanence is perhaps a coping mechanism against the fear of mortality, extended from the individual to the species. We build cities, craft histories, create art, and explore the stars as though these acts can defy entropy. Religion, philosophy, and even science often assume continuity. That knowledge will be preserved, that life will endure, that civilizations will evolve rather than disappear. The sudden disappearance of Earth highlights the precariousness of these assumptions. It forces us to confront the possibility that all our achievements, knowledge, and experiences are contingent, dependent entirely on the continued existence of a fragile planetary home. This awareness has the potential to unsettle deeply ingrained narratives of control and permanence. Moreover, this scenario reframes our understanding of fragility. Humans have long considered themselves capable of shaping their environment, influencing ecosystems, and mastering natural forces. Yet the instant vanishing of the planet underscores that, in the grand scheme, our influence is minor. Earth itself is tiny compared to the Sun, the galaxy, and the universe at large. Despite our technologies and our ambitions, we are ultimately vulnerable to forces far beyond our control. This revelation has profound ethical and philosophical consequences. It suggests that stewardship of life and the planet is not only a moral imperative, but also a recognition of vulnerability. Our efforts to preserve and understand the world gain urgency when we appreciate how easily it could cease to exist. The philosophical implications extend to our perception of value. If all can vanish instantly, how should we allocate significance to our actions? The usual metrics of success, longevity, accumulation, legacy, lose their grounding. What matters is the immediacy of experience, the quality of interactions, and the recognition that life is finite and precarious. This is not nihilism, but a reorientation of priorities. Human value shifts from permanence to presence, from expectation of continuity to appreciation of the moment. By recognizing the fragility of existence, we are encouraged to invest more fully in awareness, empathy, and understanding, knowing that nothing is guaranteed. Furthermore, Earth's hypothetical disappearance serves as a meditation on cosmological humility. Humanity tends to see itself as central, both in terms of consciousness and in shaping the world. Yet the universe operates on scales far beyond our comprehension. Our sense of centrality is reinforced by daily experience and cultural narrative, but the thought experiment reveals that even the entirety of human civilization is negligible in the cosmic order. Philosophically, this challenges anthropocentrism, inviting reflection on our place in the universe not as rulers or permanent occupants, but as temporary participants in an indifferent cosmos. The idea of a ghost planet, as observed from afar, adds another layer to the philosophical reflection. Distant civilizations detecting the absence of Earth might wonder about the causes, interpreting the disappearance in terms of cosmic events or intelligent action. Similarly, humans observing the universe and reflecting on our own existence may recognize that permanence is a fragile construct, and that all life-bearing worlds are temporary phenomena within a vast, ongoing cosmic process. The philosophical takeaway is that the universe is neither inherently meaningful nor purposeless. It simply exists, and meaning arises through conscious engagement with reality, however transient that engagement may be. Humanity's need for narrative also comes into question. We create histories, mythologies, and scientific accounts to frame existence, but if Earth can vanish instantaneously, these narratives are anchored in contingency. Our understanding of the past and projections for the future are subject to disruption by events outside our control. Philosophically, this emphasizes the limitations of knowledge and the need for humility in both science and philosophy. Even the most well-supported models of planetary behavior, societal continuity, or cosmic events are contingent on the ongoing presence of the physical world. In essence, contingency is the fundamental condition of life and existence. Yet within this contemplation, there is a paradoxical empowerment. Recognizing the fragility of life encourages intentionality, focus, and presence. If permanence is unreliable, then the conscious act of living, reflecting, and creating becomes even more significant. Our contributions, artistic, scientific, moral, are valuable precisely because they are temporary, fleeting, and contingent. Meaning is derived from engagement, not from assured continuity. The very impermanence of existence elevates its significance, reminding us that life is precious not because it is guaranteed, but because it is finite and tenuous. This thought experiment also provides a lens through which to consider environmental and societal responsibility. Humanity's stewardship of Earth is often framed in terms of moral duty, sustainability, and survival. Recognizing that our entire planetary home is fragile and could hypothetically vanish, magnifies the urgency of this responsibility. Philosophically, it emphasizes the ethical imperative of care, not only for ourselves but for the biosphere and the intricate systems that sustain life. Our fragility necessitates both humility and action. Humility in acknowledging our vulnerability, and action in preserving what is here and now. In reflecting on the impermanence of worlds, the mind inevitably turns to existential questions about consciousness, meaning, and purpose. If the entire physical basis for our lives can disappear in an instant, the significance of thought, culture, and memory must be reframed. Philosophy suggests that meaning is not a property of the universe, but a product of awareness. Even in the absence of permanence, conscious beings can generate value, understand, and connect. The disappearance of Earth does not negate the significance of experience. It reframes it, emphasizing the immediacy and relational quality of existence. Finally, the disappearance of Earth invites contemplation on the nature of fragility itself. Fragility is not merely vulnerability, but a defining characteristic of life, culture, and existence. Our planetary home, human civilization, and individual lives are fragile, but this very fragility underscores their beauty and significance. Philosophically, it suggests that impermanence should be embraced as an integral aspect of reality, prompting us to live with awareness, intentionality, and humility. Earth's hypothetical erasure is a stark reminder that the foundation of all our narratives, ambitions, and achievements is contingent, and that true wisdom lies in recognizing both the preciousness and the impermanence of existence. Human imagination has long been captivated by the notion of worlds disappearing, whether through cosmic forces, divine intervention, or technological catastrophe. This fascination permeates both ancient mythologies and modern science fiction, revealing a persistent psychological and cultural preoccupation with impermanence and annihilation. The vanishing Earth scenario, as unsettling as it is scientifically improbable, taps into a deep well of narrative and symbolic motifs, resonating with humanity's enduring anxieties about mortality, legacy, and the fragility of civilization. In science fiction, the sudden disappearance of a world is a recurring theme, often employed to explore the limits of physics, the consequences of hubris, or the vulnerability of life. Classic episodes of Doctor Who, for example, have depicted planets being erased or concealed through temporal or dimensional manipulation, prompting characters to confront the ethical and emotional consequences of such loss. The drama arises not merely from the mechanics of disappearance, but from its human impact. Families vanish, cultures are erased, and heroes are left grappling with the impossibility of recovery. Similarly, in Star Trek narratives, civilizations occasionally face existential threats that result in their annihilation or sudden removal from a sector of space. These stories frequently examine the moral responsibility of technologically advanced societies to prevent such erasure, and the emotional weight borne by witnesses to worlds ceasing to exist. What makes these fictional explorations compelling is their attention to both scale and intimacy. The cosmic mechanics may be complex, aliens manipulating space-time, superweapons obliterating planets, but the narrative impact hinges on the human, or humanoid, experience. Readers and viewers empathize with those who lose everything in an instant, allowing the story to serve as a lens for exploring mortality, ethical responsibility, and the psychological weight of impermanence. Science fiction, in this sense, acts as a rehearsal for contemplating the philosophical implications of a world vanishing. It gives form to abstract fears, translating theoretical scenarios into emotionally resonant experiences. Ancient myths similarly engage with the idea of worlds being destroyed, consumed, or radically transformed. Many cultures include stories of cataclysmic floods, sun-devouring serpents, or cosmic battles that annihilate entire realms. In Norse mythology, Ragnarok envisions a sequence of events culminating in the death of gods and the submersion of the world in water, only for it to emerge renewed. Hindu cosmology speaks of cycles of creation and destruction, where entire worlds are periodically dissolved and reconstituted. Even the Judeo-Christian tradition recounts a global flood that wipes out nearly all life, preserving only a select remnant. These myths reflect a recognition of impermanence, portraying destruction as both inevitable and transformative, often intertwined with moral or spiritual lessons. The persistent recurrence of vanishing world motifs suggests that humanity's fascination is not merely about physical loss, but about the existential implications of sudden disappearance. Myths and fiction alike dramatize the tension between fragility and continuity. Civilizations, lives, and ecosystems are shown to be vulnerable, yet their narratives persist in memory, storytelling, or cosmic cycles. This duality mirrors the psychological impact of imagining Earth itself vanishing. Even in abstraction, humans are drawn to scenarios in which familiar structures are obliterated, prompting reflection on mortality, morality, and the impermanence of life and culture. The vanishing Earth scenario also resonates because it juxtaposes the ordinary with the extraordinary. Unlike natural disasters or societal collapse, which occur within a comprehensible causal framework, the instant disappearance of Earth is absolute and inexplicable. This mirrors the narrative devices in myths and sci-fi. The world is removed suddenly, without warning, forcing characters, or, in our thought experiment, human consciousness, to confront the radical unknown. The tension lies in the impossibility of preparation or response. In myths, this often carries a moral or cosmological lesson. In science fiction, it allows exploration of ethical dilemmas, human resilience, and the limits of technological or scientific control. Furthermore, the motif persists because it bridges temporal scales, connecting human experience with cosmic processes. In ancient myths, cataclysms may be framed as divine acts beyond human comprehension. In science fiction, they may involve advanced technology or alternate physics. Both approaches confront humans with their smallness in the universe, the contingency of their existence, and the suddenness with which it can be erased. The vanishing world idea is haunting because it forces an imaginative confrontation with the fragility of not only life but knowledge, culture, and identity, concepts we often assume to be stable. The fascination also stems from narrative completeness. In stories of vanished worlds, the event is total, leaving no ambiguity about the outcome. This finality heightens drama, compelling readers and audiences to wrestle with questions of morality, causality, and survival. Similarly, imagining Earth vanishing eliminates any middle ground. There is no partial survival, no mitigation, no gradual decay. The human mind, accustomed to incremental change and temporal causality, is forced to grapple with totality. The extremity of the scenario amplifies its psychological and philosophical resonance, making it an ideal vehicle for exploring fear, ethics, and meaning. Across both ancient and modern narratives, the vanishing world motif functions as a mirror, reflecting human anxieties about permanence, agency, and the limits of understanding. It allows humans to rehearse existential questions in symbolic or hypothetical form, confronting mortality and contingency in a mediated space. Fiction and myth translate abstract fears into tangible narrative forms, offering both entertainment and insight, and reinforcing the deep-rooted nature of these anxieties in human consciousness. Ultimately, the vanishing Earth idea haunts imagination because it condenses multiple fears into a single dramatic event: the loss of life, culture, history, and presence on a planetary scale. Whether through sci-fi storytelling or mythological cosmology, this motif embodies both the awe-inspiring and terrifying dimensions of impermanence. It reminds us that worlds are not guaranteed, that civilizations are fragile, and that human consciousness is deeply attuned to the possibility of sudden, irreversible disappearance. In this way, fiction and myth provide both a lens and a rehearsal for the ultimate philosophical and psychological questions raised by imagining our planet erased from existence. Imagining an Earth that fades slowly, rather than disappearing instantaneously, introduces a profoundly different set of physical, psychological, and societal dynamics. In this scenario, the planet begins to lose mass gradually, perhaps due to some cosmic phenomenon or an exotic process that causes matter to disperse over time. Unlike instant annihilation, where the universe immediately registers the absence of Earth, a slow fade creates a transitional period of instability, a liminal space in which the familiar structures of human life, ecosystems, and planetary mechanics become increasingly unreliable. The very idea of a planet dissolving over weeks, months, or years forces us to confront not only the fragility of our physical environment, but also the limits of human adaptability in the face of gradual but inexorable loss. From a physical perspective, a gradually disappearing Earth produces cascading effects on gravity-dependent systems. The planet's pull, which stabilizes oceans, the atmosphere, and satellites, begins to weaken incrementally. Oceans would rise unpredictably in some regions and fall in others, as the redistribution of mass alters tidal forces. Atmospheric density would decrease unevenly, changing wind patterns, weather systems, and even the ability of humans and animals to breathe efficiently. Satellites in low Earth orbit, which rely on precise gravitational forces to maintain paths, would drift slowly, their orbits becoming increasingly elliptical and erratic. This prolonged instability contrasts with the sudden void of instantaneous disappearance, creating a prolonged period of uncertainty for everything that depends on Earth's gravity. For human civilization, a slow-fading Earth introduces a unique form of psychological stress. Unlike the abrupt shock of instant annihilation, people would observe changes over time, perhaps noticing subtle disruptions in tides, the atmosphere, and gravitational measurements before the consequences became catastrophic. This gradual unraveling might inspire initial disbelief, followed by attempts at mitigation. Governments, scientists, and citizens would struggle to comprehend the phenomenon, debating whether it is reversible, preventable, or the result of natural or artificial forces. Unlike instant disappearance, there is the illusion of time to act, to prepare, to survive, which paradoxically may intensify the existential anxiety because there is no clear endpoint. The prolonged duration allows fear, hope, and confusion to intermingle, producing a psychological strain that could surpass the immediate horror of sudden loss. Survival attempts would dominate human activity. If Earth's fading were understood scientifically, engineers and physicists would explore extreme interventions, from creating artificial gravity or habitats to relocating populations to space stations, moons, or Mars. Terraforming efforts might be accelerated, and space colonization would no longer be a long-term goal but an immediate necessity. Entire industries could pivot to constructing orbital habitats or underground shelters capable of sustaining life independently of a planet in decline. The logistical and ethical dilemmas would be unprecedented. Who gets access to limited safe zones, and what trade-offs between energy, resources, and survival are justified? The slow fade scenario becomes as much a societal and ethical crisis as a physical one, highlighting both ingenuity and the limitations of human coordination under existential threat. Simultaneously, environmental collapse would proceed at a variable pace. Ecosystems, already sensitive to minor shifts in climate, would experience accelerated disruptions as gravitational changes alter ocean currents, atmospheric circulation, and magnetic field interactions. Plants and animals might face migration pressures impossible to satisfy. Entire food chains could destabilize. The slow pace of disappearance does not mitigate the severity of ecological consequences. It merely prolongs the period during which collapse is unfolding. Humanity, attempting to maintain agriculture and resources, would confront the stark reality that intervention may slow but cannot ultimately prevent total loss. In this sense, gradual disappearance is as brutal in outcome as instant vanishing, but it amplifies the tension between hope and inevitability. From a cosmic perspective, the fading of Earth would also create observable phenomena for distant astronomers. Rather than noticing a sudden missing transit across the Sun, alien civilizations might record progressively weaker signals, diminishing reflected light, decreasing gravitational influence, and subtle alterations in the Moon's orbit. To an advanced observer, Earth would become a ghost planet over time, disappearing not abruptly but in slow motion, leaving a trail of anomalies in orbital mechanics and stellar observations. The gradual nature of this fading may provoke more complex scientific interpretations, potentially being mistaken for gradual decay, energy dissipation, or even intelligent manipulation. In this way, Earth's slow fade would be detectable across both local and interstellar scales, leaving a narrative footprint that is both lingering and mysterious. Psychologically, the slow disappearance magnifies humanity's obsession with permanence and control. Individuals and societies may struggle with a creeping awareness that every familiar landscape, city, and ecosystem is in flux. Unlike instant annihilation, there is the burden of watching familiar structures disintegrate, providing both the agony of foresight and the torment of helplessness. Philosophers and psychologists might note that the prolonged exposure to existential threat exacerbates anxiety and reshapes cultural priorities, forcing humans to re-evaluate their values, ethical frameworks, and approaches to survival. The gradual fade becomes not only a physical catastrophe, but a prolonged existential meditation, a daily confrontation with impermanence. Technologically, human reliance on infrastructure would be tested to extremes. Power grids, transportation networks, and communication systems depend on stable geophysical conditions. As the planet's mass and gravity weaken, engineering systems optimized for Earth's standard parameters would fail unpredictably. Bridges might buckle, towers could topple, and transportation orbits for satellites and spacecraft would require constant recalibration. The slow disappearance forces humans to improvise solutions in real time, illustrating both creativity and vulnerability. Each intervention buys only temporary stability, reinforcing the understanding that all life and civilization is contingent upon the planet's continued existence. Culturally, the narrative of survival would dominate human consciousness. Stories, media, and art would quickly incorporate themes of dissolution, loss, and existential urgency. traditions and rituals might evolve in real time to reflect the temporal compression of civilization's expected lifespan. The gradual fading of Earth creates an extended stage for collective reflection on mortality, legacy, and meaning. Whereas instant disappearance leaves no room for ritual or closure, the slow fade allows culture to adapt, mourn, and reinterpret itself, highlighting the interplay between human perception, narrative construction, and existential reality. Ultimately, the scenario of Earth dissolving slowly underlies a paradox. Having time does not equate to safety. The progressive weakening of gravity, environmental systems, and social structures prolongs human awareness of existential threat, intensifying psychological, technological, and ethical challenges. Humanity's response, whether successful in temporary adaptation or ultimately futile, becomes a profound exploration of resilience, creativity, and the limits of control. The slow fade scenario serves as a lens through which to examine not only the mechanics of planetary disappearance, but also the dynamics of hope, fear, and human ingenuity in the face of inevitable loss. In this way, imagining Earth dissolving gradually reveals the same fundamental truths as instant disappearance, albeit in a temporally stretched form. Life is fragile, human civilization is contingent, and the universe operates on scales and with indifference that challenge our most basic assumptions about permanence. The scenario forces reflection on priorities, ethics, and values, demonstrating that even the perception of time does not insulate existence from cosmic fragility. Slowly or suddenly, the planet's fate dictates the parameters of life and consciousness, underscoring both vulnerability and the profound meaning embedded in each fleeting moment. From the standpoint of contemporary science, the instantaneous disappearance of Earth, as we have imagined it, is effectively impossible. Our understanding of physics is rooted in conservation laws, principles stating that mass, energy, momentum, and charge cannot simply vanish without consequence. The mass of Earth, approximately 5.97 times 10 superscript 2 kilograms, exerts a precise gravitational pull that governs the motion of the Moon, the orbit of satellites, and the behavior of the Sun within the solar system. To erase all of that mass instantly would require a mechanism beyond anything known, violating the conservation of matter and energy, as well as producing effects far more dramatic than a simple void. The sudden release or disappearance of this mass would, according to standard physics, unleash catastrophic consequences, far beyond the calm scenarios explored in thought experiments. Yet physics also recognizes its limits. While classical mechanics and general relativity forbid the spontaneous disappearance of a planet, speculative theories invite us to consider possibilities outside conventional frameworks. Concepts in higher dimensional physics, such as those explored in string theory or brane cosmology, suggest that matter might interact with dimensions beyond our perceptual capacity. In these hypothetical scenarios, entire masses could, theoretically, shift into or be removed to higher dimensional space, appearing to vanish from our three-dimensional perspective. While entirely speculative and untested, these ideas provide a scientific scaffold for imagining scenarios where Earth might disappear without violating the apparent consistency of the observable universe in a straightforward sense. Black holes offer another angle, though one rooted in extreme astrophysics. If Earth were somehow transported into the event horizon of a black hole, its matter would no longer be accessible to the external universe. From a distant observer's viewpoint, the planet would effectively vanish, although in reality it would exist in a radically transformed state within the black hole's singularity. Such a process, while mathematically conceivable, is practically impossible in natural terms. Earth is not near a black hole, and transporting an entire planet there would require forces far beyond human capability. Nevertheless, black holes illustrate that the concept of disappearance, in some form, is not entirely alien to physical theory, provided one allows for the transformation of matter into states beyond direct observation. Exotic physics also includes notions like vacuum decay, quantum tunneling, or spontaneous fluctuations in spacetime. In certain quantum models, regions of space could, hypothetically, shift into lower energy states or undergo phase transitions that alter local matter distributions. While these events are extraordinarily improbable on planetary scales, they provide a conceptual playground for imagining Earth ceasing to exist in a localized, yet radical, manner. In such scenarios, Earth might vanish not because it was destroyed conventionally, but because the fabric of spacetime in its location underwent a shift, effectively removing the planet from our universe. The probabilities of such events are vanishingly small, but theoretically, they underscore that physics allows at least a conceptual space for scenarios that defy ordinary expectation. It is important to note, however, that all these exotic possibilities remain purely hypothetical. Current observational evidence and theoretical modeling consistently indicate that Earth is stable in its orbit, and no natural process known to science can erase a planet instantaneously. Conservation laws remain robust, and gravitational interactions ensure that mass cannot simply vanish without detectable consequences. The sudden disappearance of Earth, as envisioned in our thought experiment, violates both the known behavior of matter and the continuity of spacetime as described by general relativity. Therefore, while entertaining, these ideas are more philosophical and imaginative than predictive. Nevertheless, contemplating these extremes has value beyond practical forecasting. They allow us to probe the boundaries of scientific understanding, testing what we assume about permanence, causality, and the nature of reality. Considering the theoretical frameworks of higher dimensions, black holes, and exotic spacetime phenomena encourages both curiosity and humility. The universe is vast and largely untested, and our understanding, while precise within known parameters, is incomplete. Imagining Earth disappearing challenges our assumptions and encourages a deeper engagement with the principles that govern the cosmos, highlighting the interplay between known physics and speculative possibilities. From a cosmological perspective, even in impossible scenarios, the consequences of Earth vanishing underscore interconnectedness. The gravitational web of the solar system would immediately react to the loss of mass, triggering shifts in planetary orbits, perturbations in the asteroid belt, and subtle changes in the Sun's motion relative to the barycenter. These effects reinforce the idea that matter and energy are never truly isolated. Every object interacts with the cosmic system. Even a hypothetical, physics-defying disappearance is bound by relational consequences, reflecting the principle that nothing exists in isolation in the universe. Philosophically, exploring whether Earth could vanish draws attention to human limitations in comprehending cosmic processes. We are accustomed to thinking in terms of the tangible, observable, and physically predictable. Yet the universe contains extremes, black holes, neutron stars, quantum uncertainty, that challenge intuition and compel us to accept the provisional nature of our knowledge. Speculative scenarios, including sudden planetary disappearance, highlight the imaginative space between rigorous science and philosophical inquiry, encouraging reflection on what is possible, impossible, or merely unknown. Moreover, these explorations emphasize humility in our relationship with the universe. Even if Earth cannot vanish instantaneously, considering the possibility forces recognition of the fragility of our existence within a vast cosmic network. Humanity's technological and scientific achievements, remarkable as they are, cannot alter the fundamental laws of physics. Our survival, prosperity, and understanding remain dependent on conditions maintained over millions of years, reinforcing the awareness that permanence is always contingent and that the cosmos is governed by forces far beyond our control. Black holes, exotic dimensions, and quantum anomalies also serve as metaphors for the unknown in human experience. They symbolize the limits of perception, the possibility of outcomes beyond current understanding, and the essential humility required when confronting the universe. In the context of our thought experiment, these ideas provide a conceptual bridge between the impossible and the imaginable, allowing reflection on the interplay between certainty, probability, and cosmic indifference. Even while science says Earth cannot vanish suddenly, imagining that it could underscores the wonder and terror inherent in existence. Finally, considering whether Earth could vanish also invites reflection on the robustness of natural law. Conservation principles, gravitational dynamics, and quantum mechanics together form a web of predictability that ensures continuity of matter and energy. Any deviation, such as the instant disappearance of a planet, would not only challenge understanding but fundamentally alter the fabric of reality. Through this lens, the thought experiment reinforces both the limits of possibility and the remarkable stability of the cosmos, emphasizing that the Earth's continued existence is not guaranteed by magic but by the rigorous, predictable workings of universal law. In conclusion, while the laws of science firmly deny the plausibility of sudden disappearance, speculative physics allows for imaginative excursions into the extremes of possibility. Higher dimensions, black holes, and quantum anomalies offer conceptual spaces for considering what cannot occur within our observable reality, illuminating both the limitations and the potential of human understanding. Ultimately, Earth's hypothetical vanishing is less a question of feasibility and more a tool for exploring the boundaries of physics, philosophy, and existential reflection, highlighting both the fragility and resilience of our cosmic home. Earth's hypothetical disappearance offers a stark reminder of humanity's fragile place in the cosmos. For all our technological achievements, cultural milestones, and scientific understanding, our existence is tethered to a single planet, orbiting a modest star within a vast galaxy. This perspective forces recognition that life as we know it is not inherently secure. The disappearance of Earth, whether instantaneous or gradual, highlights the precariousness of our environment and the delicate balance that sustains complex life. In contemplating such a scenario, we are confronted with the scale and indifference of the universe, a vast expanse where stability is temporary, and permanence is an assumption rather than a guarantee. Appreciating this fragility encourages a philosophical humility, acknowledging that our survival is contingent upon forces beyond human control. Climate, gravity, cosmic events, and even the slow evolution of the Sun all contribute to a precarious equilibrium that allows life to flourish. Recognizing this precariousness shifts perspectives, emphasizing the need to cherish and protect the biosphere that enables our existence. Humanity's awareness of its vulnerability is not merely existential but practical. It underscores the importance of stewardship, resilience, and long-term thinking. This awareness fuels both ethical responsibility and the drive to expand our presence beyond the confines of a single planet. The lessons extend beyond philosophy into tangible motivations for space exploration. If Earth were the only refuge for life in the solar system, any catastrophic event, natural or human-induced, could lead to total annihilation. Contemplating the disappearance of Earth reinforces the importance of developing off-world habitats, advancing technologies for sustainable life support, and pursuing planetary colonization. The Moon, Mars, and orbiting space stations are not merely curiosities or long-term goals. They become potential lifeboats in a universe where fragility is inevitable. Thought experiments like this underscore why investment in space technology, research, and infrastructure is not optional but a strategic imperative for the continuity of life. Moreover, expanding beyond Earth offers a form of existential insurance. While no human-made habitat could replicate the full complexity of Earth immediately, even partial self-sufficiency in space provides redundancy for the species. The survival of humanity does not have to rely solely on one planet. By distributing life across multiple environments, Mars colonies, orbital habitats, or eventually interstellar missions, we reduce the risk that a single catastrophic event could wipe out our species. The thought experiment of Earth vanishing crystallizes this principle. Redundancy in habitation is not speculative luxury, but a safeguard against cosmic contingency. The fragility highlighted by Earth's hypothetical disappearance also frames the urgency of technological advancement. Current space exploration initiatives, from robotic missions to human-crewed projects, are often incremental in their scope. However, contemplating a world that could vanish instantly encourages acceleration in innovation, improved propulsion systems, closed-loop life support, and sustainable energy in extraterrestrial environments become not only scientific milestones but existential necessities. The motivation to explore is no longer abstract or aesthetic. It is rooted in survival, awareness of vulnerability, and the drive to ensure continuity of life in the cosmos. In addition to practical considerations, the scenario carries philosophical and cultural implications. Human curiosity, resilience, and creativity are central to the response to existential risk. Space exploration is not merely an engineering challenge. It is a manifestation of humanity's drive to transcend limitations. The Vanishing Earth thought experiment forces reflection on what it means to be a species aware of its potential impermanence. It reminds us that intelligence and consciousness are rare phenomena, and that preserving and extending their reach is both a responsibility and an act of self-expression. Expanding humanity's presence beyond Earth is an exercise in resilience, vision, and the acknowledgement of our place in a vast universe. Furthermore, considering the fragility of our home planet fosters international and collaborative perspectives. The threat of sudden or eventual planetary loss is universal. It does not respect borders, politics, or culture. Global coordination in space exploration, resource management, and disaster preparedness becomes a shared imperative. Recognizing our collective vulnerability encourages collaboration rather than competition, aligning humanity toward common goals of survival and continuity. Lessons drawn from imagining the loss of Earth, therefore, extend from scientific and technological domains into societal and ethical spheres, promoting a cooperative approach to existential challenges. This thought experiment also illuminates the interdependence between exploration and knowledge. Developing space infrastructure requires deep understanding of physics, biology, engineering, and environmental systems. As humans venture further into space, we gain insights into planetary dynamics, cosmic hazards, and the possibilities of sustaining life under extreme conditions. Earth's hypothetical disappearance acts as a conceptual motivator. By imagining the worst-case scenario, we recognize the value of preparedness, research, and technological foresight. The lessons of vulnerability directly inform innovation, guiding humanity toward solutions that strengthen resilience and expand horizons. Beyond survival, the drive to explore catalyzed by this scenario fosters long-term vision. A species confined to a single world is vulnerable not only to physical destruction but also to stagnation, limited perspective, and the eventual depletion of resources. Expanding into space encourages adaptability, curiosity, and a broader understanding of cosmic systems. Thought experiments about planetary disappearance serve as catalysts for ambition, motivating humans to think in terms of centuries and millennia, rather than immediate lifespans. In this sense, the imagined fragility of Earth becomes a source of inspiration, driving exploration and the pursuit of knowledge on scales previously unimaginable. The psychological impact is significant as well. Understanding that Earth is impermanent encourages a collective shift in consciousness, valuing life and ecosystems, prioritizing sustainability, and cultivating foresight. It encourages societies to invest in education, research, and infrastructure designed not only for comfort but for resilience against existential risks. By confronting the possibility of total loss, humans are reminded of the preciousness of their existence and the interconnectedness of life across temporal and spatial scales. This awareness reinforces ethical responsibility and motivates action in ways that routine survival alone might not. Finally, the thought experiment highlights that space exploration is intertwined with identity and purpose. The potential fragility of Earth challenges humans to redefine what it means to thrive as a species. Survival is not merely biological. It encompasses knowledge, culture, and the capacity for consciousness to persist. Expanding beyond Earth ensures that humanity's achievements, understanding, and awareness are not confined to a single, vulnerable planet. The lessons are clear. Fragility breeds responsibility, awareness fosters innovation, and the recognition of vulnerability motivates both exploration and stewardship. In conclusion, imagining Earth's disappearance underscores the urgency of space exploration, the value of scientific advancement, and the importance of philosophical humility. Humanity occupies a delicate position in the cosmos, and survival requires not only local stewardship but also the expansion of our presence into new environments. By reflecting on fragility and vulnerability, we are motivated to explore, innovate, and collaborate, ensuring that life and consciousness can endure beyond the bounds of a single planetary home. This thought experiment is not only a meditation on impermanence but also a call to action, to protect, preserve, and extend the reach of humanity across the stars. The overarching thought experiment, it is valuable to reflect on the cascade of consequences we have explored throughout this journey. We began by imagining the immediate absence of Earth, and from there, we traced its effects across the solar system, on life, on culture, and even on distant civilizations. Each layer revealed the delicate interconnections that sustain not only life on Earth, but also the broader cosmic environment in which our planet resides. Gravitational shifts, the Moon's uncertain fate, the perturbation of nearby planets, and the asteroid belt, all demonstrated that Earth's presence, though seemingly small in the cosmic scale, is pivotal to the structure and stability of the solar system. Without it, the intricate balance maintained for billions of years would unravel in subtle yet profound ways. On a more intimate level, the immediate loss of life would be absolute and total. Every human, animal, and plant would cease to exist, and the accumulated knowledge, culture, and achievements of civilization would be erased in an instant. History, art, science, and memory, everything that defines human existence, would vanish along with the planet. The thought of such abrupt erasure elicits an emotional response unlike any other scenario, a combination of awe, sorrow, and existential humility. It reminds us that our lives and the continuity of culture are far from guaranteed and are instead dependent on a singular, fragile planetary home. Even small environmental changes, let alone complete disappearance, underscore our precarious position in the cosmos. From a cosmic perspective, Earth's absence would not go unnoticed, even from afar. Distant astronomers or hypothetical alien civilizations would detect anomalies. The sudden loss of reflected light, disruptions in gravitational patterns, and the disappearance of a familiar transit across the sun signals we sent into space, whether radio communications or probes like Voyager and Pioneer, would continue moving outward, carrying echoes of a civilization that no longer exists. The planet's erasure would thus leave a kind of imprint, a faint and silent testimony that something once inhabited that orbit, even if the beings themselves are gone. This concept reinforces the poignancy of existence. Even as life and matter are transient, traces of consciousness can ripple across space, giving a kind of indirect immortality to human presence. Philosophically, the vanishing of Earth underscores the impermanence of all things. Our civilizations, achievements, and even the physical planet itself are contingent, fragile, and temporary. We live under the assumption of continuity, but the thought experiment strips away that assumption, revealing the underlying vulnerability of our existence. It challenges our understanding of meaning, permanence, and priority, asking us to consider what matters if the very ground beneath us could vanish. In this light, the experiment is more than a hypothetical scenario. It is a meditation on the values and awareness that give significance to life. Fragility amplifies value, and the awareness of impermanence deepens our appreciation for what we have. The human legacy, though ephemeral, also emerges as a critical theme. Even if Earth were gone, the evidence of our existence, our technologies, our signals, our attempts to reach beyond the planet, would extend into space. This reveals both our vulnerability and our resilience, fragile beings capable of creating traces that outlast the medium of their existence. In a sense, the thought experiment highlights the duality of life. While all is ultimately contingent, the impact of consciousness, creativity, and knowledge can extend beyond immediate survival, offering a form of continuity through observation, influence, and remembrance. Emotionally, The disappearance of Earth invites profound reflection on the uniqueness of our planet. Its oceans, atmosphere, biodiversity, and the precise conditions that make life possible are the result of billions of years of cosmic coincidence and natural processes. Earth is a singular cradle for life, unlike any other known location in the solar system. Imagining its removal magnifies its value, emphasizing that the extraordinary complexity of our home is both rare and irreplaceable. The thought experiment fosters awe and reverence, reminding us that the privilege of existence is tied not just to life itself, but to the exceptional environment that sustains it. The scenario also resonates with timeless human questions. What is our place in the universe, and what does it mean to exist in a cosmos indifferent to our survival? In exploring the consequences of Earth vanishing, we confront the scale and impartiality of the universe. Planets, stars, and galaxies continue to follow their paths regardless of human presence. The thought experiment, while tragic, is also clarifying. It situates humanity within a vast framework, emphasizing both our smallness and the profound significance of our conscious experience, however fleeting it may be. Finally, the scenario compels reflection on responsibility and action. The fragility of Earth is not only a theoretical concern, but a practical one. Our planet's ecosystems, climate, and stability are under constant strain from human activity. Recognizing Earth's vulnerability, even in imagined, extreme scenarios, underscores the imperative to steward and protect the home we have. Awareness of impermanence can inspire careful management of resources, sustainable development, and thoughtful exploration beyond our planet. Thought experiments about planetary disappearance serve as catalysts for both ethical reflection and pragmatic motivation, reinforcing the link between awareness, action, and survival. Returning to the original question, the scenario is both terrifying and illuminating. Considering Earth's sudden disappearance allows us to appreciate the intricate balance of life, the interdependence of cosmic systems, and the singularity of our planet. It reveals the contingency of existence, the value of consciousness, and the importance of preparing for the fragility inherent in any finite system. Through this lens, we gain perspective on our priorities, our responsibilities, and the awe-inspiring complexity of the universe that surrounds us. So, what if Earth suddenly vanished from the universe tomorrow? The answer is simple. Everything we are, everything we know, would vanish with it.